Hello, in this video we're going to look at sketching the graph of this equation. As you can see, it's a quadratic, so we're going to end up with a parabola, which is just the smiley face or sad face graphs. Okay, first thing, 4 features of a quadratic. We've got y-intercept, x-intercept, axis of symmetry, and turning point. Lock those in your mind. And let's start over on the left, finding our first feature, the y-intercept. Y-intercept, you let x equal 0 in this equation. So y equals x squared, take 4x plus 3. If I let x equal 0, I just replace 0 with x's in the equation. I mean, x's with 0 in the equation. So 0 squared, take 4 times 0 plus 3. Now to simplify that, BIDMAS says brackets and indices first. So 0, take 4 times 0, 0 plus 3, y equals 3. And I like to put int there to remember that that's our y-intercept and put a box around it so you can easily find it because we've got a lot of features to find. So I found our y-intercept. X-intercepts. X-int, let y equals 0. What happened there? So in our equation, y equals x squared, take 4x plus 3. If we let y equal 0, it's that. And at this point, people get a little bit confused because it's not quite easy to solve. So you need to remember with quadratics, you're going to need to factorize in order to solve. So go back and watch my factorizing videos if that doesn't make sense. But let's have a look. Factorize means put it into 2 pairs of brackets, okay? In order to factorize an expression with 3 terms in it, we are going to need 2 numbers that multiply to give the end number. And they add to give the same 2 numbers, add to give the middle number. Make sure you take that sign at the front too. So luckily, 3 only has 2 factors, right? 1 and 3. But so 1 and 3, 1 plus 3 gives 4, but we need to end up with a negative number, okay? Now the only way for it to continue to be a positive number up here is to make both of those numbers negative. A negative times a negative is a positive. That's the only way to do it. So really get some practice with negatives and positive numbers if this is confusing. And just doing a double check, -1 times -3 does give 3. -1 plus -3, getting more negative on the number line, that works. Now we have factorized, so we can write that right-hand side as factorized. So x take 1, x take 3. And then the next step, let's actually move that up a bit. To solve that is the null factor law, which says if 2 pairs of brackets, if 2 things multiplied by each other equal 0, then one thing must equal 0 or the other thing must equal 0. So this is just written like this. Null factor law, x take 1 equals 0 or x take 3 equals 0. And then just you solve for x. X equals 1. If we add 1 to both sides, x equals 3. So these are actually our x-intercepts. So remember, if you run into an equation which doesn't seem to be easily rearranged, that is a key to factorize. So we have now found our x-intercepts. We'll put boxes around them. Now we've got our axis of symmetry. Our axis of symmetry, axis of sim. And I'm just going to write x equals ... because that is the equation of our axis of symmetry. When you have a quadratic, it's it's the line x equals something, which I did in my last video. So please go back and watch that. I explained it. So axis of symmetry, this is the formula you want to remember. X int plus X int over 2. It's halfway between your x-intercepts. And we have our nice box around them, so 1 plus 3 over 2. Simplifying the numerator, 1 plus 3 is 4 over 2, which is 2. That's our axis of sim. Maybe put a line next to it, axis of symmetry. It splits the graph in half. Now, one more thing to find, and then we can finally plot it. Find the turning point. Now, the key with the turning point is that it is a point. It's an XY point. And the key is that the X coordinate of this, you might need to pause the video and have a break before understanding this. The X coordinate of your turning point is the axis of symmetry. So we already have half the turning point if we found the axis of symmetry. So I'm going to put that there. Remember, points are x, y, right? Now, remember what you're given. You're given an equation linking x with y. So that's how you're going to calculate to find that corresponding y value. So I'm going to write down my equation. And I'll write down my equation. Y equals x squared, take 4x plus 3. Sub x equals 2. That's the key to this. To find y, you need to substitute in your axis of symmetry to find the full turning point. Let's substitute it in. So wherever there's an x, you're going to put a 2. So y equals 2 squared, take 4 times 2 plus 3. BIDMAS. Brackets, no brackets. Indices first. So 2 squared is 4. And then you can also do multiplication at the same time. So I can see some multiplication. Negative 4 times 2, negative 8 plus 3. And then you can just put that all in your calculator if you like. But I can see 4 take 8 gets me to the negatives. Negative 4 plus 3. Negative 4 plus 3 is negative 1. And that's going to be the y coordinate of my turning point. So I'm just going to fill in that little box. That little box has found me my turning point. And there we are. So we are ready to plot. We're ready to plot our quadratic on here. We've found all the 4 features. Let's put them in. Y-intercept is 3. So over here, y-intercept is positive 3. So this is our x-axis. Let's move this over a bit. This is our y-axis. Y-intercept cuts the y-axis. 1, 0, 1, 2, 3. Done. X-intercept is 1 and 3. So there's 2 x-intercepts so let's put that in. That was the y-intercept. And we've got 1 and 3. We're getting there. We've got our y-intercept, x-intercept, axis of symmetry. Axis of symmetry down below was x equals 2. See that? And now that confuses people sometimes. So you might plot the turning point first and put in your axis of symmetry last. So let's actually put our turning point. The point 2, negative 1 lies here. So TP 2, negative 1. And I can draw a line through those features. And I just need to remember that my axis of symmetry cuts it in half. And even though, let's actually do that in orange. Our axis of symmetry is in orange. And it is a vertical line. Think of those special linear graphs. A vertical line looks like a y-axis, but it has the equation x equals whatever we calculated it to be halfway between those x-intercepts, which is 2, or where it cuts the x-axis. Sorry if I confused you. That is what the graph of this quadratic looks like. So hopefully that made sense. You might just want to come back and watch steps 3 and 4, finding that axis of symmetry and turning point. But I will see you in the next video. Bye-bye.